All right, you guys, here we are with our last section of notes for chapter 5. And so, yes, as I warned you, there are 5 more formulas for this section. These are called the double angle identities. So the reason why they're called double angle is because all of these have cosine of 2a, sine of 2a, tangent of 2a. And remember, a is the angle, so 2a would be a double angle. And so these are a little bit different. You'll be able to recognize them because, for example, see down here where you're given cosine of 2 theta, that's your clue that it's a double angle formula because there's a 2 there with the angle. It sometimes is an a, it sometimes is a theta, it sometimes is an x, so we use different variables for these. But for this very first problem, it's not a double angle, this is a regular angle, so I know that by combining this and this, I can figure out what quadrant I'm in. So if the cosine of theta is positive and the sine of theta is negative, that tells me I'm in quadrant 4. So I'm going to draw a picture here of cosine of theta of 3/5 in quadrant 4. And so that's going to be the first thing I'm going to do. Draw a quadrant 4. There's my triangle. If cosine is 3/5, remember that's x over r. My r is 5, my x is 3, my other side, my y is -4 by Pythagorean theorem. So I use Pythagorean theorem to get 4, and it's negative because it's in the 4th quadrant, and y is negative there. And so this problem now is asking me to find sine of 2a, or 2 theta, cosine of 2 theta, and tangent of 2 theta. So I'm going to do 3 different problems. The first one I'm going to do is sine of 2 theta. I'm going to zoom in a little bit. And looking up here, cheating a little bit, looking at my formulas, here's my formula for sine of 2a. It's 2 sine a cos a. In this case, they're theta, so I'm going to replace all the a's with thetas. But my formula there is 2 sine theta cos theta. And so I'm going to keep this coefficient, this multiplier of 2 out in front, but I'm going to use this triangle to do sine of theta and cosine of theta. So my theta is here, it's my reference angle. The sine of theta is -4/5, and the cosine of theta is 3/5. We were actually given that also in the problem. We were given cosine, but we needed to draw the triangle to find the sine. Okay, so remember when you multiply fractions, you just go straight across. If it helps you, you can put this 2 over 1. What you're going to do is 2 times -4 times 3, and that gives you what? -24. And when you do the denominators, 1 times 5 is 25. So this is the sine of 2 theta. Okay, the question also asked me to do cosine of 2 theta, so I'm going to slide over a little bit, and I'll do that over here. Cosine of 2 theta, well, what's hard about this chapter is that there's actually 3 formulas for cosine of 2 theta, or 2a. You can use whichever one you want. In this case, because we have our triangle drawn over here, it doesn't matter. You'll get the same answer no matter what you do. I'm just going to go ahead and try this first one. I'll use the first one. There are 3 because you'll see later when we start looking at identities and stuff, sometimes it's easier to tell which one to use. In this case, it doesn't matter. I'm just going to use my first one. This one. So it's cosine squared theta minus sine squared theta. So don't get that confused with one of our Pythagorean identities. If it was cosine squared plus sine squared, it would not equal this, it would equal 1. So it looks really similar to one of those identities that we already know, so just be careful about that. Okay, so my cosine of theta, my cosine was 3/5. I'm still using this triangle here, and since it's squared, I'm going to square 3/5. And the sine of theta, looking at that triangle over there, was -4/5. But again, it's sine squared, so I'm just going to square the whole ratio. And so that means, remember when you square fractions, you square everything, the numerator and the denominator. So that makes 9/25 minus 16/25. That means my final answer for cosine of 2 theta is -7/25. Okay, and again, you would get that same exact answer, this one, if you used any of those 3 formulas up above. I'll talk in a little bit about when to use which one. Okay, the last part of this question is tangent of 2 theta. Here's our formula for that one. It looks kind of similar to the tangent formula that we've already used, the tangent sum and the tangent difference formulas, but in this case, tiny bit different. And so what I'm going to do is write it over here. Tangent of 2 theta equals 2 tangent of theta over 1 minus tangent squared of theta. So again, I'm just looking at the triangle that I drew over there. So I have a 2 coefficient. The tangent of theta, let me see if I can swing over to that. The tangent, remember, is the y value divided by the x value, so it's negative 4/3. Negative 4/3 over 1 minus negative 4/3 squared. Okay, so now I just need to clean this up a little bit. What you could do again is put this 2 over 1 and you're just multiplying straight across, so we get negative 8 over 3 on the top. And the numerator, this is going to be, or the denominator, 1 minus 16 over 9. So I'm going to change this to 9 over 9 instead of whole number 1. And that gives me negative 7 over 9. And remember how to divide fractions. You keep the numerator and you flip and multiply by the denominator. And so my 3 cancels here and makes that a 3. Negative 8 times 3 is negative 24. The negatives cancel, so positive 24 over 7. Here's where the trig is not difficult, the algebra is difficult. You have to be okay simplifying fractions. Just multiply straight across here to get this. I changed my 1 into 9 over 9 so that I had a common denominator with this. This negative squared away when I squared the negative 4/3, and that's why I got positive 16/9, but that negative sign stayed. And that's how I got negative 7 over 9. Flip and multiply, negatives canceled, divide that by 3, divide that by 3, and now multiply straight across. All right, now I'm going to get into a more difficult example. This one is a little bit harder, and we're given a little bit of a hint here. This tells me that I'm in quadrant 2, except I can't draw my triangle using this because this isn't cosine of theta, this is 2 theta. This is one of those double angle formulas. So in my triangle I have a theta here, but I do not know how to label it yet. All I know is that it's in quadrant 2 because I was told here in the problem. So what I need to do here is use one of those formulas that's above for cosine of 2 theta. And I have a formula, I'll just pick the sine one. Cosine of 2 theta equals 1 minus 2 sine squared theta. And unfortunately, you guys, sometimes it's like doing one of those identities. If you would have picked a different equation for cosine of 2 theta, if you use like the cosine squared and the sine squared one, it would just be harder to solve. And you might get halfway through the problem and go, you know what, I'm going to start over and I'm going to use a different formula. In this one, in order to solve for the regular theta and not the 2 theta, I would pick one of the formulas that only has a sine squared or the cosine squared in it. You don't want to have the one that has both sine and cosine in it. That would be really difficult to solve. Okay, but the reason why I'm doing this is because we are given in the problem the cosine of 2 theta. It's 4/5. And so what I'm going to do is replace, doing a little bit of a substitution, 4/5 with cosine of 2 theta. And now what I have to do is just solve for the sine squared theta, which eventually will be just solve for sine of theta. Okay, so first thing I'm going to do, I'm just trying to isolate this. Let's just use some algebra skills to clean this up a little bit and simplify. I'm going to subtract 1 from both sides, which is the same thing as subtracting negative 5 over 5. That's a common denominator. So that's going to give me negative 1/5 on this side, and I have negative 2 sine squared theta on this side. Now what I have to do is divide both sides by negative 2. Divide by negative 2. Remember how to divide fractions. That's going to give me 1/10 over here when you flip and multiply, equals sine squared theta. And remember, what I'm trying to do is get regular theta so that I can label my stupid triangle all the way over there that I haven't even put any numbers on yet. And so in this case, I have sine squared theta, and the way to get the sine by itself is to square root both sides. When you do that, you need a plus or minus. And then we will decide based on the quadrant whether I'm going to use the positive square root or the negative square root. And so this means that sine of regular theta equals plus or minus, after you rationalize, radical 10 over 10. And I need to decide whether the sine in quadrant 2 is positive or negative. In this case, since I'm in quadrant 2, the y value is positive, so I am going to use positive radical 10 over 10. since it's in quadrant 2. Okay, so that was just doing a lot of algebra again, but that's, remember, y over r. So I'm going to label my y radical 10 and my r regular 10. And then by doing Pythagorean theorem, what I can do is subtract and solve for the missing side. By doing Pythagorean theorem here, that gives me this squared is 100. When you square this, you get 10. 100 minus 10 is 90. And the square root of 90 simplifies to 3 radical 10. Okay, so again, that was just Pythagorean theorem. You can pause the video and actually work it out if I lost you there. But that's Pythagorean theorem. And remember that it's negative because it's in quadrant 2. The x value is negative there. Okay, so finally I have my triangle labeled, and that's why I said this was a more challenging example. But it says find the values of the 6 trig functions. So now all I have to do is all 6 trig functions for this triangle. So what I'm going to do is zoom in a little bit. I'm going to pause the video. You can work out all 6 of them, but now we're pretty much home free. So here's all 6 of them, you guys. Just keep in mind that you might have to rationalize some of these, so be careful. In the tangent one, it's radical 10 over negative 3 radical 10, and those radical 10s just cancel, so just don't forget your 1 on top. And then flip all those fractions, and these rationalize, so stop and pause and actually show your work if you weren't able to do that in your head. But that's why we're just flipping the sign to get the cosecant, and then rationalizing. You're flipping the cosine to get the secant, and then rationalizing, and then flip this to get cotangent, okay? I think I'm going to stop there. I know there's quite a bit that we still have to finish, but I think that's enough of an introduction right now to some of those formulas. And then I want to do a lot more in class together, and then we'll spend the next couple days kind of mastering this stuff. Don't forget, you guys, about the formula quiz that's coming up. You have a couple options of days of when you want to take that. But as a suggestion for you, just to knock it out of the way and to be more successful for the rest of the chapter, I would get these memorized very quickly and try and knock that out. So that it just helps you in the long run, and so you're not cramming in the last minute, okay? Thank you guys for watching. Definitely add these. These are the last formulas for the chapter. Add them to the back of your unit circles. Bring your questions to class, and we will go through some more of these notes tomorrow, okay? Have a great night, you guys.